It all began with a dream, a profound and audacious human aspiration to reach out beyond our own world. A profound and audacious human aspiration to reach out beyond our own world. In the summer of 1977, humanity launched two remarkable emissaries into the vast dark expanse of space. These were the Voyager probes, Voyager 1 and Voyager 2, our silent ambassadors to the cosmos. Our silent ambassadors to the cosmos. Their initial mission was one of planetary exploration, a grand tour of the gas giants that orbit our sun in the cold, distant reaches of the solar system. Each probe carried with it a golden record, a time capsule of sorts, filled with the sounds and images of Earth. There were greetings in 55 languages, the chirping of crickets, the cry of a newborn baby, and the timeless music of Bach and Chuck Berry. It was a message in a bottle, cast into the cosmic ocean, a hopeful testament to a small, blue world teeming with life and wonder. The first leg of Voyager 2's incredible odyssey was the Grand Tour, a breathtaking flyby of the outer planets. Its first stop, in 1979, was the colossal king of our solar system, Jupiter. It gave us our first detailed look at the Great Red Spot, a swirling anticyclonic storm larger than our entire planet, a storm that has been raging for centuries. Voyager 2 unveiled the intricate, multicolored bands of clouds driven by ferocious winds and discovered several new moons, tiny worlds caught in Jupiter's immense gravitational pull. 2 years later, in 1981, Voyager 2 arrived at the jewel of the solar system, Saturn. It danced through the planet's magnificent ring system, revealing a structure of baffling complexity. What we had seen from Earth as a few solid bands were, in fact, thousands upon thousands of individual ringlets, woven together like the grooves on a phonograph record. It studied the hazy orange atmosphere of Saturn's largest moon, Titan, a world with a thick atmosphere, hinting at a complex chemistry hidden beneath its clouds. In 1986, it reached Uranus, a pale turquoise world tipped on its side, its axis of rotation pointing almost directly at the sun. The final planetary encounter occurred in 1989 as Voyager 2 flew past the deep blue world of Neptune. It was here that it discovered the Great Dark Spot, a massive storm system reminiscent of Jupiter's. It captured breathtaking images of Neptune's largest moon, Triton, a geologically active world with nitrogen ice volcanoes erupting from its frozen surface. After its spectacular tour of the planets, Voyager 2 embarked on the second and perhaps most profound phase of its mission, the journey into interstellar space. For decades, it sailed through the outer reaches of our solar system, a region dominated by the sun's influence. This vast bubble carved out by the solar wind, a constant stream of charged particles flowing from the sun, is called the heliosphere. It's our solar system's protective shield, deflecting much of the harsh cosmic radiation that permeates the galaxy. Voyager 2 passed through this shockwave in 2007, confirming its existence and sending back crucial data about the physics of this distant region. Then, on November 5, 2018, it happened. At a distance of more than 18 billion kilometers from Earth, Voyager 2 crossed the heliopause. This is the true outer edge of the heliosphere, the point where the sun's solar wind is finally stopped by the pressure of the interstellar medium. The probe's instruments detected a sharp drop in solar particles and a dramatic increase in high-energy galactic cosmic rays, the telltale signature that it had finally left home. It had entered the space between the stars. As Voyager 2 settled into its new environment, its instruments began to paint a picture of interstellar space that was utterly bewildering. For decades, our models had predicted that the transition from the heliosphere into the interstellar medium would be relatively smooth. But the reality that Voyager 2 reported was startlingly different. Instead of getting colder, the plasma, the sea of charged particles in interstellar space, was significantly hotter than models had predicted. In fact, it was blazing hot, with temperatures reaching an astonishing 30,000 to 50,000 degrees Celsius. The region just beyond the heliopause appears to be a wall of fire, a superheated boundary layer that we had no idea existed. It suggests that the interaction between our sun's solar wind and the interstellar wind is far more violent and complex than we ever imagined. This single, astonishing discovery from Voyager 2 is forcing us to tear up the old textbooks and start again. For years, our models of the heliosphere were built on assumptions about the interstellar medium being a relatively calm and cool place. Now, we have to rethink that entire picture. The discovery of this superheated plasma wall suggests that the boundary of our solar system is far more dynamic and energetic than we ever conceived. It's a place of immense pressure and temperature, a cosmic battleground where our sun's influence clashes violently with the galaxy. But if our own backyard has such a strange and unexpected feature, what does that mean for other star systems? It could imply that every star creates a similar superheated boundary. This would fundamentally change our understanding of how stars interact with their galactic environments. Voyager 2's incredible journey and its paradigm-shifting discoveries are not an ending, but a beginning. Inspired by the success of the Voyager program, scientists and engineers are already dreaming up what comes next. A mission currently under consideration is the aptly named Interstellar Probe, a spacecraft designed from the ground up to explore this mysterious boundary. Each new mission will stand on the shoulders of the one that came before, pushing the frontier of our knowledge ever further. The story of Voyager 2 is a profound reminder of what humanity can achieve when we are driven by curiosity and a desire for knowledge. Its journey continues, a silent testament to our own journey of discovery. As it sails ever onward into the great star-filled darkness, it leaves a trail for us to follow, beckoning us toward the next chapter in our exploration of the cosmos.